Okay, so what we're going to be looking at here is an example from the 2021 exam. This is a graphical analysis to be done without a calculator. So let's go ahead and jump on in. Here we go. It says, let f be a continuous function defined on the closed interval from -4 to 6. The graph of f consisting of 4 line segments is shown above. Let g be defined by g of x equals the integral from 0 to x of f of t dt. Now, what we have to realize real quick is we're going to be asked a bunch of questions about g, so we need to understand how g is related to the graph that we're looking at up here. Hopefully you can see if we take the derivative of g, that is equal to f of x due to the first part of the fundamental theorem of calculus. In other words, this is a graph of the derivative. And as long as you understand that, most of these questions are fairly easy to answer. So the first question says, on what open intervals is the graph of g concave up? Well, if I have a graph of the derivative, that is anywhere that the original function, the derivative function is increasing. So from -4 to -2 and then from 2 to 6, those are the two places where g would be concave up, and that is just because f is increasing on those intervals. So that one was pretty easy, not too bad. Letter B says let p be defined by p of x equals g of x times f of x, find p prime of 3. Well, in order to do that, I need to find the derivative first, so I've got to use the product rule. So I get first times the derivative of the second, plus the second times the derivative of the first. So I do that, and then I plug in 3. So I get g of 3 times f prime of 3, plus f of 3 times g prime of 3. Now, strangely enough, f of 3 is by far the easiest to find. That just means look at the graph, and I can see that the y value is -3, so that's f of 3. And because this is a graph of g prime as well, g prime of 3 is also -3. So both of those are -3. F prime of 3 is asking what is the slope as we pass through that point, so that's going to be 1. I just need to find g of 3. The way I find g of 3 is I take my function and I plug 3 in for x. That's asking for the area from 0 to 3. Well, I've got a triangle there and a triangle here, and those areas actually cancel each other out, which means I just have a trapezoid right here that I find the area of. So it's below the x-axis. I'm going to have -1/2. Base 1 is -4. Base 2 is 3. I'm using the positive version since the negative's out front, and then there's a base of 1. So that is -7/2. Now, if you want to figure out what that is when you add all those together, you could leave your answer just like this, but if you want to find out what the answer is, you'd have to get a common denominator, and it turns out that the correct answer there is 11/2. Not that you need to simplify. Letter C says find the limit as x approaches 2 of g of x divided by x squared minus 2x. As is usual, the first thing we always do is we plug in our limit. In this case, g of 2, that's the integral from 0 to 2. Just like we talked about before, that triangle and that triangle are going to cancel each other out. So I get 0 on top and then I get 0 on bottom, which means I have to use L'Hopital's rule to find out what this limit is. That's take the derivative of the top, g prime of x, and the derivative of the bottom, 2x minus 2 separately, then evaluate the limit again. So I get g prime of 2 over 2 squared is 4, or 2 times 2 is 4 minus 2 is 2. G prime of 2 just means look at the graph and say that the y value is -4 divided by 2, which gives me -2 for my answer. Okay? The only hard question I thought on this entire problem is letter D, because it wants the average rate of change on g, which means I'm going to have g of 2 minus g of -4 divided by 2 minus -4, so that's like 2 plus 4, which is going to be 6. The problem is I have to find both g of 2 and, so that's the integral from 0 to 2, which we already know, that one is 0, so that one's actually easy to find. And I have to find g of 6, or excuse me, g of -4. So that's going to be the integral from 0 to -4 of f of t dt. Well, really, in order to do that, I'm going to flip it upside down and make it -4 to 0 of f of t dt. I am looking for all of this area right in here. So really, I think the easiest way to do that is make a triangle there, make another triangle there, and then you've got a trapezoid, and that will tell you what g of negative 4 is. So I'm going to have 6 on the bottom. I'm going to have 0 right there. Now I just need to find out what that is as well. And so I've got that triangle. That's 1/2. The base is 2. The height is 6. Plus I got that trapezoid 1/2. Base 1 is 6. Base 2 is 4. Then I times that by 2. Then I've got plus 1/2 times, I got that triangle as a base of 1 and a height of 4. And so all of that would go in right there, and that would be your answer. If you want to simplify that down, you get 16 over 6, I believe, which is, if you simplify that, that's 8 over 3, which is the correct answer there. Now it also says, does the mean value theorem guarantee a value C such that G prime of C is equal to this average rate of change? On letter C, it said that on letter B, I think, one of them said that it's continuous and differentiable, okay? That G is. Since G is continuous and differentiable, which means, I mean, you think about it, it says that G is continuous. Since the derivative exists everywhere, that also means that it is differentiable on that interval. So since it's both continuous and differentiable on the interval in question, we can use the mean value theorem. I know that's a little bit confusing because usually we look at this graph and trying to determine that, but it's asking about G, which is a separate graph. This one had a decent amount of algebra, but the ideas on it I didn't think were overly difficult. If you have any questions about this, please let me know.